So in this exercise, what I'm going to do is I'm going to use George Williams, another one of George Williams's exercises. This time it's about in his chapter on grading for circulation. And so I'm using his worksheet on page 107. So what I've done to start with is I've inserted those two using the picture command into Rhino. I'm working in Rhino 7 here. I've just upgraded, very excited. And Rhino is the best value piece of software you can buy and always worth having your own private version. Plug. So for this exercise, I've brought both documents in there and I've rescaled them. And I've kept a bit of the worksheet, the information for worksheet above and also this below. And I've then created if we look at my series of layers here, you'll see that what I've done is I've already created the contours and lifted them to their level using the gumball, which I presumably I'm now going to have to turn it on. Yep. So using the Z to move them up to their elevation, and I've also created a surface for one surface I've used the way that I've been doing it previously is to create extract points from using the extract points command from the contours to get a series of points. And then from that, I've then created a patch surface. But I've also created a grasshopper surface as well. So I've just got both of them there now. This is not so important for right now, but rather than explaining all of this in this exercise, I'm starting with contours lifted into place and surfaces already undertaken. So I'm going to do this exercise in Grasshopper, and I'm not going to do it exactly. I'm not going to work with the super elevations that William specifies. I'm going to treat it like there's a uniform curve all the way along. And basically the operation is that I'm creating a profile of this profile here in Grasshopper, and then I'm going to sweep it along this path along here. And so what I'm doing is I'm really going to use that center line as the rail curve, and then I'm going to use this as the swept profile. So I'm going to create that profile in Grasshopper, and I think this is a useful process more generally because I think that landscape and urban design often works with standard sections. So in a lot of my urban design work, I'm working with standard sections to establish street profiles so that you can work with sliders, etc. And so obviously I'm going to kick up Grasshopper. And if it's glitchy because I don't know yet, 7, I'm assuming it's going to be roughly the same. So to start with, what I'm really going to do is I'm going to, this is where I've tried this twice before, and previously I've tried to create the center point and work this all out from the center point, and it actually ended up being more complex. So what I'm going to do first is I'm going to create a point in the in the Rhino side. And then of course I'm going to get a point parameter, which we know because they're black. I'm going to set one point, right click and then set one point for this point here. And it's just below, like if we look at where this is, it almost doesn't matter where it is. In fact, that's actually the wrong view. So I'm going to delete that point, and I'm actually going to go and create a new point again. So I'm setting that in front. I want to set it in top. So instead what I'm going to do now is go over here and do exactly the same process. So that's now my starting point. And so I'm actually going to set this one here to set view top so that I can have above here, I can have the section that I'm trying to work from and trying to simulate. And then over here, I can have the point that I'm using as my base. So what I'm going to do is I'm going to create the center, the crowned curved road section first. Then I'm going to mirror the two shoulders on either side. And then after that, I'm going to work on the different factors. So the way I've been doing it previously and the way I want to do it now is I'm going to create a grade calculator. Now, I've been working previously for using, sorry, it's a preview of one of my lectures that I've been giving recently, is that what I've been working on is, where am I? Where is George's fabulous book? There it is. And so if I go through here, I'm working with the most simple of calculators, which of course is the GDL or GLD. Oh no, sorry, yeah, DLG triangle. And I mean, this is I use this all the time, and I think it's the most useful way to remember it. Remember your own nomic to do it. But what we can do is we can always unpack it by saying, if we want to know what D is, which is the difference in vertical difference, we can say D equals L times G, like here. If we want to work, if we know what the length is, we can go D over G. And if we want to know what the grade is, we know that grade equals D over L, where grade is the decimal. And so that's always there. And so what I'm going to do to start with is I'm going to set up a calculator. And I've been doing that in a dumb way, which has just been saying, here's 1, and that we would literally go sort of, and I can say 100. And then I can set up a calculator. We know here that it's 1:50. And so I'm just really setting this up as a dumb calculator for grade here. And so we know that if this is 1:50, what I'm trying to find out here is I'm going to start by creating a SDL line. And so, I know that where my point is, that's my start. And so what I'm ultimately going to do is I'm going to eventually move towards creating an arc 3-point. And so at that point, I'm then going to use this calculator up here to be able to work out my vertical difference. So I'll come back to that. And so we're trying to work, if we look at this view here, this top view, we can see that I'm trying to move across. We know that the road is 10 meters wide. And so, the most obviously when it says D for direction, it's easiest sometimes to just put in a vector. So I'm going to put in unit X to go in the direction of the X axis along there. And then the length, of course, is 10,000, and I'll just go 10,000. And then if I plug that in, we have a line that's 10,000. So that's just giving us our basic thing. Now, I'm often in the habit of grouping things together. And so I drag a window over them, press Control or Apple key G, and then that groups those components together so I know what they're about. So now I've got a line. Now, if we look at that section above in the top window, we can see that the crown is in the center of it. So what I'm going to do start by doing is I'm going to divide that curve. And that's to give me the middle point. Now, it would be easy just to have a command called midpoint, but this is how I've been doing it at least. Now, obviously you can see that it's divided that curve into a whole lot of points. If we want to see how many, we can hesitate over the top of N, which is the count, and you see it's got 10 in there. Now, we know there's a lot of ways to specify that. I could go 1:10, 1 in the direction of 10, which creates a slider to get 1, which is just no division, or 2, which is what I want. But I could also do this where I can actually, if I want to, and I know it's not going to change, sometimes it's easier just to go set integer and then type in 2. And so this is an easier way to do it. If I had to potentially change it around, I might use a slider. So I divide it into 2, and now you'll see I have 3 points. When I click on it, you'll see them there. And if we click over here, hesitate, we see it's defining those 3 points. Now I want the middle point. So if we use a list item, then what we're doing then is we're plugging that in, and we've got, we can see that it says I here. Now that means that that's actually the first item in the list. One way we could get to the 3 items, and again, I'm showing this in numerous ways, is to show how those options work. We could go 0, and we could go 0 to 0 to 2, and then we could use that to select a point. I'm noticing here that the first point in the list is always 0 and 2. Like, that's a way of doing it. That's the way I did it for a long time. But we also know that in a way, if this is the first one, then if I zoom in here and I click plus, it's like whatever the first one is +1, we know that one then gives me the middle point. And so now what I'm going to do is I'm basically going to draw a line upwards, because now I'm going to try to get that curve. And so if I go line SDL again, then at this point, the first point I'm going to go to is this is the +1 point. So that's the middle point. The direction we know is actually, if we look at the axis in here, the vector is Y. I plug that in there, and then it's about what is the length. And so this is where my calculator comes into bearing. And so, you know, obviously, the basic way to get the decimal of this is to use the divide command, divide, you know, or division. And then if I divide 1 by, you know, by that, we get the figure, which is the decimal of that grade, which is 1:50, it's 0.02. So you see, that's just the basic, and that's just like rise over run, right? 1/50, that's the way we get it for running a division. So if I go back to my calculator here and we be clear about what we're thinking of, what we need to know is the vertical difference, And so we know here that difference is grade times length. And we have all those components already. And so if I choose multiply, because it was a multiplication, if you remember, and I say multiply, and I don't really need to keep that one there. I just did it to show you guys what the number was. If I go multiply and I choose that length of 10,000, and those things there, and then put this here, we'll see that our difference in elevation is 200 millimeters. So that's what the size of the crown is at 1:50. And so now what I'm doing is I'm also going to group that calculator together. I might use it together again. And so now all of the rest of this is all about getting this right. So if I move this here and we do that, you'll see that I then end up with a little line here. So there, I've now got all of I now just need to extract the endpoints off that. So if I type endpoints like this, I've then got all the information I need to get an arc 3 point. So I'll group that together because that's all one function, essentially. So now if I get an arc and I choose arc 3 point, I know that the first point of the arc is the one that I started with, this point here. I know that the second point is the end. Now I know it's the end because the SDL, the direction was Y, starting off with this center point here. So then what I'm doing is I'm choosing that as the second point. And then to get the third point, it's really the end point of this line. Now, you know, there's a whole lot of ways I can do it, but at least I know that, you know, if I can either get another endpoint component the same way that we were, or I can extract, you know, we divided that into 3. And of course, because of that, I can also just add another thing there, which because it's 1, 2, 3, or 0, 1, and 2, with 0, 1, and 2, I can then plug this one into there and I get my curve. And so that's the way for me to have got this thing. Now, all of those components are related to each other. And so I'm going to group all of those together. And this is just my workflow method. So I'm going to group all of those together. And then I'm going to right click and I'm just going to say that this is just going to call this one what's the term they use for it? We're just going to call this the road surface. And that way, all of those components are tied. Now, I want to turn off a lot of stuff here because I'm not really needing it. I'll turn off the previews for all of these components. Now, when it's a geometric component, it doesn't really matter whether it's previewed or not. I mean, whether it's a numerical component, it doesn't matter if it's previewed. And so if I just go to that, all I now have is my arc, which is the main component I want. Now we have to do the shoulder. Now, interestingly, we can do this in a similar sort of way. where we can just sort of, we can copy, which is what I'm going to do. If I get all of that, those three components there, and I go and I hold the Shift button down, and I go Control C, Control V, I then have all of that pre-made line. And so what I'm going to do now, obviously it wants to know where the start point is. And if you remember, I plugged in a whole lot of things. So I'm after this point down here. And so if I change that to this point, which is the end of those, 0, 1, and 2, 0, 1, and 2, and I get that and I plug that in there, we then should then have, it's turned off, so I have to turn it or preview it on again. You'll see there is the line. It shows here that it's 2 meters. So I'm going to change it to 2000. And so then we have that line. Now here we're going through a similar process again. Those give me that line, so I'll group them together. Now what I'm really looking at is I'm going to do an SDL downwards, because I'm going to draw a line from there, angled line from there down. And so if I go endpoints again, I get both of those endpoints there. And at that point, then what I'm doing is really, I've got those endpoints and I'm now trying to work out how to go down. So this is where I'm going to create another SDL line. And if we look at where it's going, we can tell that when I drew that line, it started from here. So that's the first point, the start. This is the end. So the start is actually the line I want is the end. The direction, if you look at it, there's Y, there's X, there's Y, sorry, there's X. So I want to go Y. So I'm going to choose unit Y. But if you see that I'm going downwards, and so therefore it's actually negative. And so at this point, what I'm doing is I'm going to plug this under direction and that way there. So it's negative Y, so it's going downwards. Then I have to work out the length. And now at this point, that working out of the length is actually very much the same already as what we've been doing previously. So if I click on this and then I hold the Shift key down, you'll see that the top of this is going to the existing calculator. So this is already at 1:50. Now, maybe it's worthwhile me doing it separately, so I will do it separately. So if I choose to, I'm going to choose at this point to get that calculator again. Control C, Control V. And now what I'm going to do is I'll group it. And if you remember that multiply was the function that we were talking about. If we go back to this calculator, I'm still trying to find the D, which means that it's D equals G times L. And so that's the way that we calculate that. And so here I'm then going, well, we're going to stick with it 1:50, which is fine. We know what the L is, which is 2000. So if I get a multiplication, and I choose 2000 times the grade at 1:50, and then I can plug that in there, and we should see that that line goes downwards, and there it is. And so I also then get so I'm going to group those guys together again. I choose endpoints. And so now I have everything I need for the next segment. So the next segment is really another line, but this time it's a line between 2 points. So it's just create a line between 2 points. Note that it's not the black one. The black one is the parameter that would be taking information from Rhino, but this time we're generating information in Grasshopper. So I take that and I'm choosing 2 points. Now, obviously I've already got the endpoints here, and so this time I want the start point, and then I want the end point from this one. And you'll see how now I have that second line. So obviously, it's obvious to say this, but if I wanted to make that 1:1:2, say I wanted to make that 1:20, I could do that, and you'll see how it shifts around. So that's just to demonstrate the fact that Doing it like this is more laborious, but ultimately, if we later on wanted to change this road profile around, we can. That's the whole reason we use Grasshopper. In a way, if you're going to use one instance, hell, you may as well actually just model it in Rhino. But this is about a way of thinking that allows for refinement and versioning, as Wasim calls it. So I'm going to group all of those together again. This time I'm going to go through and I'm going to turn off the preview for all of the things except for that last line that I want. And then I've got just that line and this, and then I can, now I have one batter. Now, what do I have that on? And so, funny, it looks different, huh? 1:50, 1:50, you know, oh. You know what I've done wrong here. Interesting. Can you tell me what I've done wrong? I can tell you. That's pretty interesting. So obviously I've assumed here that my whole grade of 10 meters is falling down. But in actual fact, it's from the center line. So because I'm looking at this, I'm like, I'm not sure that's working how I want it. So what I actually need to do is I actually need to divide that total in half, because it needs to be of half the width. So it's actually dividing that there into 2, because I'm working with half the road. You know, if I hadn't done it, I wouldn't have picked it up, huh? So it's useful. Yes, and so there it is, right? So now we can see that's an interesting thing. When you're working, because I've worked this time from the point on the left, not from a center point, this is partly what's happened. So that's good to know. So now, you know, it doesn't really matter so much, but I'm gonna move all of this, move this here, back onto this canvas here, and then I'm just gonna regroup. It doesn't matter if there's 2 group on group in there, really. But that was a good pickup, last minute. You know, could have created online embarrassment in that process. So that's given us just one side. What if we want to mirror it on the other side for the same shoulder, because you see how it's there on both sides. So what we want to do that is we want to mirror, you know, and I'm just using mirror an object. Now, you know, what object am I mirroring? I'm mirroring this line to put it on the other side. So let's plug the geometry in there. It'll turn up in some other random part of the world because the mirror plane has to be worked out. You see, it's all the way over there. Now, if we think about the mirror plane is actually based on the center point there, because this road has a center point. Now, I found this out through trial and error, so I can't imagine why you guys, makes sense when you think about it, but we're talking about a mirror plane because otherwise we're mirroring 3D. How are we doing that? And so the mirror line, if we look at this axis, it's actually going to be along the center, so it's Y. But in actual fact, to get a plane to go straight up to us, Z is in that plane. So if I go YZ, Y and Z, then what I'm doing is I've got that plane there that I'm mirroring in. And what about the actual middle point of this? Now, the middle point, if we can think about it, we know that we had this arc, which was A, B, and C. B is the midpoint of it. So what happens if I choose to use that as the origin? And what happened there? I plug it into the origin and you'll see that we end up with that mirrored on that side. And so the origin basically means the point at which there is which is the origin for that new plane. If you can imagine, it's coming out vertically from the y-axis, like a vertical extrusion from the y-axis that we're seeing on the screen here, up vertically. And where would we start that from? Well, we'll start it from there. Now, I'll put in a point just to show you where that point was and to see that that's the point there. That's the middle point. I often put these things in just to actually show us where we are. Sometimes I delete them. Sometimes I'll do the same with a line. I'm not using it for any other reason than I want to see what is that, what is that the start point? What is the end point? That's my way of seeing it. So just when you see that plane, you can imagine that that's actually coming from that point as its origin, but then coming up in this sort of vertical vertical plane off the y-axis towards Z. Okay, so then I've now got these two, and so that's now the next component that I can join together. And if I join all that together, then what we have, oops, I joined everything, but if what we do, we join those ones, you know, then I can call these ones, you know, shoulders. Now I could actually, you know, road surface, I'll stick with that. So that's now, we've now got like the main parts. Let's turn off some other things. I need that mirror, I need that mirror. You know, probably the rest of it can all stay. That's my original starting point. So, you know, because that's a point, this is all adhering to that. So if I move that around, you know, it's, yes, it's drawing in plan on my 3D drawing, but I can hide it somewhere that you don't really see it, or I can even turn it off later. So that's given us those two, those major, those symmetrical parts. Now we've got to do two other parts. And so the process that we're going to do now to create the channel on the right-hand side is actually very similar to, you know, to what we were doing previously. So I could copy it, but in the way, it's probably just easier to draw it. So if we look at this line here, we've got, as I said, we've got these points already. Let me plug in a point and find out where I'm actually looking here. That's the endpoint. That's where I want to start this 200 channel. So now what I'm going to do is I'm going to do an STL again. So it's the same process I started with, STL. And then I'm going to say that the start point is this point here. The direction again is X, because we're moving in that way. Let's turn this gumball off. You know, so now I've now got a direction, and the length is 2000. So if I just type 2000, you know, I get that same thing. And so now I've got another little length. You can see it there, right? So that's the line. Again, it's a guideline. Now this time we need to draw, to work out, we have to draw this sort of, this channel, it's 200 deep. And so what I can do is I can actually then, I can go Control C, Control V, and I can copy that over again. And what I can do for this line is I can actually copy, where am I? You know, if I get those two components there, Control C, Control V, and move them across, I could just use those components, because I can say that's my curve. You know, I've got 3 points there. If I preview that, you can see there's now 3 points there. Just copied that across, nothing special about that. You know, and then what I'm doing is I'm drawing another line. This time I'm going to use Y, unit Y, and I'm going to use negative again. And I'm going to ungroup that. I'm going to plug those two into each other. I'm going to delete this guy, move this over to here. You can see that the line start is not the right one, so I want to plug it into this middle one here, and I want to set it to 200. And there's the 200. So there we've got that line, and I'm going to get the endpoints of that line. So now we can see that we've got that, that's that line. And we've got these guys here. So if we want to draw that arc now, we go to arc 3 point again. Now we know that the start is the same start point that this one had. So the first point is that. Now we know that for this one, because we drew the line down, the start is there, the end is there. So an end point for that. And then at this point, we know that this line has 3 points, and we know that's the end point because the start, middle, end, we plug that into there and we end up with that arc. So now we have that side. Very good. And so this time, you know, I'll do the same scenario again. I'll turn off all of the construction geometry. Now, maybe you're not like me, but when I learned CAD, not everyone uses CAD these days. A lot of people are using Revit, fair enough. we built construction geometry to make lines. So this is not that, not that unusual. In this situation, and we'll call this we'll call it channel. And, there is the channel. So now we've got the shoulders, the lines, the shoulders, the channel. Now we have these two embankments on either side. Now, the way that we do this is, because the method that I'm going to use is similar to one I used in one of my earlier videos, is that I'm basically going to create banks that are angled and that are way longer than they need to be. So I really don't, all I care about is the grade. I don't really care about whether or not how long they are, because ultimately I'm going to intersect this geometry with the landform. And so in a way, one is going to be cutting, one is going to be filling. And so I'm not really worried about how long they are, because it's where they intersect, which will use one of the intersect operations to work out. So what I'm going to do in this situation is that I'm going to create an SDL again, as you do. And this time I'm actually going to, what I'm going to do is I'm really going to create a line that I'm going to use as a vector first. And so in this situation, like I can use exactly the same. So let's copy our calculators, right? I've already generated these guys, Control C, Control V. Oops, where are they? They're over there. So I'm going to get this over here. And I'm going to start doing this in a very simple way where I'm just literally going to, and this is, again, there'll be a faster way of doing this, but we know that this side is 1:3. In actual fact, I can even do this in a more basic way. Since I've been doing it this way already, I can even just do this in an incredibly more basic way, which is to say that I can get this, I can do it as an SDL, and I can say that the start point, which we know the start point is basically the third point of that curve there. Then I'm going to just move, I'm going to start by literally just pegging this out. I'm going to move across by distance. So I'm going to say distance is X. And then the length is 3. Now, again, you're not even going to see this. I mean, let's zoom in until we can see it, right? It's going to be tiny. And that's fine, because all I'm doing is I'm actually just creating a vector. So that's my first vector. And so now what I'm doing is I'm going to do the same process again. I'm going to do a SDL. And again, I could draw this totally differently to how I'm doing it, but I'm improvising it. And so at this point, obviously, I want to get to the endpoints, same process. So, endpoints, we know that that's the end there. So that we're talking about the end. The direction this time is Y, unit Y. And now what I'm going to do is I'm going to move the 1. Sorry, wrong way around. I messed that up. I'm going to plug, that's actually the direction. The length is 1. And so now what we have is that we have essentially another 2 lines, construction geometries, and I go to end again. And this is, again, there's going to be much simpler ways to do this. We could do this numerically if I wanted to, but this is dummy maths, Raxy way of doing it. And so now I'm doing a line again. And so, yeah, like I said, this is dummy maths. There's going to be real grasshopper people who are on here who are like, what the hell are you doing it this complex way for? I'm sorry, that's just the way it happened. line from there, start point, point A. This one is the end point, point B, and then we have that line. Now, the reason why this is useful, of course, is that a line is also a vector. And so what we're doing now is that if I now go and say SDL line, and then I can use this line as the direction. And then what I can say is that the start point is the same start point I had before. And then I can sort of set the length of, let's set it as 10,000. Or let's set it as 5,000. You can see that what we've done is that first triangle, which is literally just the grade triangle, it's the basic module of the grade triangle. You'll see that that is actually setting the grade at this point here, right? So if I wanted to make it steeper or shallower, I can do that. But they want 1:3, so let's do 1:3. And so, as I say, if I want to make it less length than that or longer than that, I can. So that's fine. So that's just one method that I've been using. Now, again, I'm going to turn off all of this construction geometry. Because ultimately, this is all just creating me a vector. And I'll even put that in there. Just so we remember what this is doing. I'm going to call this the grade vector. Because it's really just using its directionality. That's why we plugged it into D. And so then, we've got how long it is. Now, again, it doesn't really matter at this stage until we know later how long it is or needs to be. Maybe put in as 5,000 just in case. So that's that one. So now what I'm going to do is, those ones, that whole one is the cut batter. So I'm going to just call that, name that one cut batter. Now I have to create a fill batter. And so this is where it's a bit of a mind flip to do this, but it's a similar process. So I'm going to go Control-C, Control-V. So now what I'm doing, if you can imagine, is I'm working on the other end there. Now, if we look at where our construction geometry is, what we're going to have to do is we're going to have to start using some negatives in this process to get the same effect. So we're going to have to be a little bit careful here about how we unpack this. And so obviously, we have, this was the mirror, right? That's that one. So if I'm going to start by getting the endpoints of that mirror, because I'm now working on the opposite side. So I'm working on this end over here. And so if I've got that at the end there. And so now I'm obviously going to be working on the end point of it because of the fact that the mirror has its start here and its end over here. But let's check, as I've been doing. Let's plug the point in and make sure that I'm right. Is that the end? Yes, it is. Good. Is the start of the first part of the grade vector. So I'm going to plug that in. And if we look at where that, and I'll turn that line on, where is that line now? Now, this is where it's interesting. Let's find it. Where is it? Oh, of course, it's actually tiny, right? So let's go back here again. Oops, don't even know what that is. Yeah, okay. So you'll see that really that line is not the one that really, well, it is kind of the line that really matters, but you'll see that it's actually down over here. Like if I look at this, you'll see that's my line. So first of all, I'm also going to have to move a few other points. And so I'm going to move the endpoint because we're starting at that point. So then now it's plopped over here. So that's a good result. But, you know, I think that this is where, if we look at what happens when we change the angle of that, you know, nothing is really happening in a pronounced way here. So this is because of the fact that that point there, I'm going to zoom in on it and have a look at it. So can we see straight away that in actual fact, it's pointing in the wrong direction. So what we're going to need to do is, and I'm going to ungroup this again and get these components worked out. You'll see that the first thing we need to do is we need to put a negative in here. So that's to just make sure that that line is going in the correct direction. See, there it is. That's just the line that is 1:8 at the moment. But in actual fact, you know, if we look at where it's going, we can see that it's, you know, it's going in the wrong way. We know that this line here is 1:4. Now let's just turn this line off and see what's happening with our angle where we want it to. And obviously, that direction is fine. You know, what happens if we change this angle up and down? So there's something funny happening there. So is that because of the fact that, let's now preview this guy in here, and remember that it's right down in there. So let's now see what's happening in there. Let's turn this line on. This is where sometimes the debugging process just isn't worth it, right? So here we can see that the length, you know, the length here, what are we getting here? You know, I'm debugging this component. Is it making my life any easier to be debugging it? Where is that line? You know what? Let's have a look here for something. Let's first of all see, is that the point? Aha, what happens when I change it to that point? Yeah. Now, is that where I want it to be? Not really. You know what we learned in this process is that the debugging stage is almost worth just redrawing it. But I'm in this debugging stage, so let's do it. There's the first line. That line is about the length. From that, we're getting an endpoint. And I've chosen to use this one as the endpoint. But in actual fact, I then plugged this one. So let's now move that to that other point over there, which is the endpoint. And let's move this also back to what it really wants to be, which is to 4. So now we should find that we have a line. We have this one. Aha, interesting. So we do want to go, we can see here that we're actually looking to go down. So this is the debugging process is working pretty well. So now what we're doing is we're actually going negative, and then we're plugging this into here, that into there. Theoretically, if I preview that, this is interesting. So of course it's starting at the wrong place. So this is where we need to look at this point and say that it starts from there, and there is our grade. And so do you see that I had to kind of reorientate all of that geometry? So yes, you can copy it, or you can do it again. Depends what ends up being easier for you. I would almost say that it's easier to do it again, but educationally there's a value in doing that process. But you know, you can spend a lot of time. We probably did spend a lot of time on that. And so, you know, it's over here. We've now got that other line That's our grade. What's our grade? 1:4, that's good. And so now we have the whole section that we're talking about with the fill batters and the grade, etc. We change this so it's symmetrical. And so now we have all of the parts that we had before. Now I'm going to do the same process again. I'm going to group all of this. I'm going to call this one fill batter. And I'm going to go through and turn off all the components the same as I did before. Previews, turning off all of those previews. So I think the main thing to remember is that when I was reorganizing this, the things I was reorganizing were none of the function, none of the parametric, none of the numbers. I was changing orientation. So I was making Y's negative and X's negative and then changing the starting points of it. So if you think about it in those ways, that when you copy a piece of geometry, you have to change the relational start point, and then you have to potentially change the orientations to make them negative because we're working down, so negative Y, and we're working negative X because we're working towards the west of the drawing. Those are the really simple things that we had to do, but sometimes, even with all this organization, it's hard to find those components. And so, you know, this is where, in the end, I've got that line. So the key thing before we have a quick coffee break is that I'm going to, if we look at this with the components we've got together, the things that's also useful to do at this moment, which I often do, is that I actually merge the geometry to create a single piece of geometry. And so I do that by using the merge command. And so this, what I do is it's basically like plugging the finished pieces of everything into each other. So I'm going to start by merging that arc, which is the road surface in there. Then I'm going to merge I'm actually going to, it doesn't really matter so hugely, but I'll try to take a common sort of sense of it. I'm going to then merge this component in there. Then I'm going to merge that arc, which is this component in there. And then I'm going to start to the other side. So I'm going to merge the mirror, which is the other shoulder in there. So I'm clicking, you can see that all these pieces, oops, actually undo that. I'm actually going to merge the cut batter in there. So I've done everything onto the right-hand side. Then I'm going to plug in the left-hand side. I'm going to merge that component in there. And then I'm going to merge the final fill component in there. And if I click on that, it should have everything. Now, if I go and choose join curves, I can plug all of that together. And you'll see though that at the end it says two components. What I'll need to do is flatten that. And when I flatten it and rest over it, it's now one curve. So at this point, I can turn that off as well and join those two together. And I now have one piece of geometry. And so at this point, I can then turn off all of the individual components or turn off the previews of those individual components, keep them enabled, never turn the enabling off. Otherwise, you end up with parts of your algorithm not running. So, you know, turning off all of those previews all the way back to here, so that in the end, I'm working with the one that's the most recent one, really. That's the aim. And so they should all be turned off or not previewed. And in the end, I should just have this one curve. Now, finally, what I'm going to do is that I'm going to set a new insertion point. And this is really important because if you look at this drawing, you'll see that there is a center point marked. And if we look at the actual thing that it's going to be moving along, there is the center point marked here. And so what I'm going to do is I'm going to make sure that this road has a center point. Now, if I return to the original arc that I had here, we know that point B is the center. So what I'm going to do is I'm just going to get a point like this, and I'm going to choose that point, and that should be the middle of the road. Yes, it is, because then we've got the other part here, then we've got the shoulder, then we've got the curve. Don't forget, this was our original point. And now what I've got is I've actually got the, I'm also going to turn off or turn the preview off of this original point. So the reason why this is important is now what I have, if I move these two over here, is that I have the center point, and I also have the, the curve. I'm going to call this complete profile. Okay, and so at this point, I'm just going to take a quick break. Resuming now, what I'm also going to do is, I've got all that geometry now. That's all of my curve and this whole road profile. So, I'll, leave it there together like this. I mean, I probably could gather it together. I often do, but there's not going to be that many components from now on. So first thing we'll need to do is that we'll need to, on a new layer, so I'm going to just move this away for a moment, is I'm just going to rename one of these layers, and I'm going to call it center line. And then I'm going to create a new sublayer on that, which I'm going to call center points. And here, again, we've got these two top things set up. And so if I choose, zoom back out from here again, you'll see that there is a table here. And, I've discussed this before in my class, but, for people out there, I mean, I used to call these, knew these called on the road projects I was working on in terms of surveyors, this idea of chainages. Williams is calling them stations. He probably knows much better than I. And so to start with, what we're doing in the Rhino side is we're going to just plop in some points. And so now that point's there, we need to set that point to, because it's meters, 29400. So what I'm going to do, and I'm going to pause while I do this now to not waste your time, I'm just going to go in and create all of those points. So what I've done is I've actually put in all of those points there according to this process of locating them on that base plan and then lifting them using the gumball and the Z axis to move them to height. So what I'm going to do is I'm going to make the curve actually in Grasshopper. So if I go to point and then I go to right click set multiple points, then what I can do is I can really just go make my way through. Oops. And so I am going to, I've done that in the wrong order. So it's never always worth remembering that you should not, if you can avoid it, you need to set the order of things extremely carefully. So let me turn off some stuff so that I'm not confusing what I'm doing. I've already locked the images. And so what I'm going to do now again is I'm going to choose point. And then I'm going to choose set, right click, set multiple points. And I'm going to go along and I'm going to very carefully choose the points in sequence. As I say, problems come when you stop when you start putting things out of sequence in this program. So I've got those there, and then I can use from curve. I can choose the option that is actually under spline. I can choose, interpolate, and if I choose to put them in, you'll see that I end up with that curve there. Now there are lots of options in there about how you can manipulate the degree of the curve, how the period of the curve, how to deal with knots. But I'm just going to use the default for now because I'm not that exact in my knot work and my curve work. So I'm like, I don't think I really need it. I'll group those together for now. So now there's a command that's important that's called perp frames. Very important. And so this is where, you know, what we're doing here is that we're what we're doing is we're getting the curve and we're putting that in there. And in actual fact, it chooses a number of planes. Now, at the moment, you can see that if we zoom in here, will we see that the planes are there? Let me see. What we can do is that we can actually use a slider and we can say, like, you know, what happens if I choose 30, for example? If I choose 30, you'll see that you can't really see all of those frames, but there was basically going to be a whole lot of frames along the this geometry, according to how it sets it up along that curve. And so what we're going to use is that we're going to use the command orient you know, this is where it can go terribly wrong. And so I'm going to be playing here. And so what we're going to do at this situation is it says, what's the initial plane? We plug that into there. So first of all, here's the geometry that we're oriented. Then what's the initial plane, which is A. And then it wants to know where are the other planes. And, you know, this is where you can see that we now have 30 of these planes. Now, this is where I have to tell you that I use a method which is really unprofessional. I don't know, something or other, but it's loose. And that method is really that I kind of rotate things. So, you know, what I'm doing is I'm really going to sort of potentially rotate I'm going to set this to be in degrees. I'm going to set the geometry as being that curve. I'm then going to plug this into this geometry here. And then I'm going to set the plane as this one here. And then in this situation, what I'm going to do is I'm going to say 0 to 360 and create a slider. And that slider then plugs into there. And what I'm really going to do at this point is I'm going to play around until I get what I'm looking for. Now, obviously, we know that that's the wrong way around. So if I choose, what happens if I choose 180? What happens if I choose 270? You know, we can see that it's still in the wrong orientation. And so this is where I'm going to, you know, if we remember, this is the downhill side. So let's go back to 0. Let's go back to 90. And then what we can see actually is that it is completely the wrong way around. And so therefore we'll have to mirror it. So yes, with a greater depth of understanding the geometry, I could actually be able to do this in a more basic way. And so what I'm going to do is, because I drew this in this original way, I'm going to go YZ as my mirror plane. And I'm going to choose the origin as there. I'm going to then do this. And then I'm going to choose that. And then I'm going to plug that into this side. And so what I've really done there is I've kind of just, you know, if we consider that I really had this curve, like if I zoom out and we look at this situation here, you can see how these are the operations I've been doing, is mirroring, rotating, orienting. And so the reason I'm doing it this way is that there is going to be a clear geometric reason why this is the wrong way round. But instead, what I'm doing is I'm just going to keep just basically rotating it around until it's fitting to the correct orientation. And in a way, that's the start orientation to this thing. And so now what I've done is I've got this, I've got this here. And then what I'm doing is I'm going to turn off, or, it doesn't matter really so much, but I'm turning off all of these previews. But I've now got that geometry roughly in some sort of location that's roughly correct. And so at this point, what I'm going to do is I'm going to use a sweep and sweep 1, and it wants to know where the rail is. And of course, the rail is that curve that I interpolated already. And so if I then choose the rail as being that curve, and then it wants to know what is the section curves, and I go like that, what we end up with is that surface there. And if I, shading it doesn't make any difference because it's in Grasshopper, but you can see how that is there, that curve is there in that way that I've created. And so now what I'm doing is I've got those pieces of geometry. I'm going to do some grouping again, because all of that was about sort of setting up that situation. I group that as well. Well, in actual fact, really logically, I could actually be putting that more up there, because it's really more about that side of producing the curve, the sweep. So I'll group all of that together, and I'll just call that sweep. I'll make sure that we know that this is the rail. I've now got that there. Now, if I look at let's just take a sort of quick and dirty look at what's happening. If I turn my patch surface on, we can start to see how this guy is or isn't actually. I mean, let's now shade it. We can see that there is actually, in this structure, it is kind of a bit above and a bit below this whole thing. And so in actual fact, it's not as uniform as there being this thing. I mean, let's try looking at what happens when I choose the Grasshopper surface. It's roughly the same, right? And so part of the reason why it looks like this is actually because of the fact that I'm not using a super elevation on this road. And so because of that, what I'm doing is I'm not correctly showing how this works, because what the super elevation means is that there'll be an angled camber around this. And so to make this really work properly and to do it the way that I want to be doing it is about really understanding how this thing is going to sit in this landscape. And so really it looks, if we just read the way that this is sitting right now, what we can tell is that, let's do the patch surface, it's sort of more elegant in some way than the Rhino surface, than the Grasshopper surface. What we can see is that, yes, there is parts of fill, but in actual fact, most of this thing is in cut. And so if I now, and this is what we're going to do for the class in Studio, is that part of this exercise is now in the grading subject is to work out how to make this best fit. Now, one of the most obvious ways to do this for this exercise is to begin the process of moving points up and down. So, for example, if I look at the fact that there is a series of points under here, that there is a point at the end here, like let's put it, we should be able to see that point, right? Is there. One thing to do to start with is to play around. And so let's pan this down a bit further, is to begin to play with actually moving that curve up. Now, if I, so can you see here that that what I'm doing is I'm sort of interpolating. Each time it's interpolating a new curve. And so this is now about trying to find ways to balance, to balance cut and fill. And if I have another one of these, which is this top view here, and I then render that top view, then what I can be doing is I can be seeing that, if I remember rightly, then this is the line of the shoulder. This is the line of the edge of the roadway. That's the center line. There's the shoulder. There's the swale. These continue further out. And obviously, one thing I can do also is these probably are not extended correctly. So if we think about the fact that I have the cut batter, what I can actually do is I can continue that further out. That's 10 meters, right? So that tells you that if that's not disappearing in there, that tells you that we're actually already, we're too high out of the ground. And so if we kind of then go back into this space here, and I choose that point again, what happens if I go negative 500? You see how the cut batter is now, the fill batter is reduced, so it's actually tapering off. Let's make it another negative 500. There it's tapering off. But we can see that the cut side is quite pronounced, right? Well, in actual fact, no, that's not true. The cut side is way out. So I suppose it's the situation where we might find, like if we zoom around here, is there actually going to be cut? And so the next exercise, and this is the exercise for the students, is to sort of get Williams's profiles and get this system, and to then interpolate it to say that, okay, let's play around with how we can get this existing alignment to sit better. How much cut and fill is there? How can we drag it around? Maybe we end up putting fill on both sides. Maybe we have cut in some locations. And so I think it's really about setting that system up. And it can be visually worked out in this way. So, I mean, at the moment, if we look at it, then it looks to me like at the moment there is virtually no cut. Let's have a look. When we're at this position here, there is a little bit of cut, right? There's a little bit of cut. We can see the swale disappearing in there. And so really, if we think about looking at these embankments, we can really play around with how those heights are and whether or not we have to mirror fill on both sides, cut on both sides. And then at this point, what we then do afterwards is we then move into the process from my previous tutorial, as we did for the platform, where we start chopping, we start intersecting the meshes with each other to create the lines of no cut, no fill. We start subtracting from the meshes below to come up with the final landscape. So this is the sort of process we're going through in the process of making this work. The main thing I want to talk about here is actually really using Grasshopper to create a sectional profile to extrude, and then how to sweep it. And now the next stage, I think, is how to make it so that it fits in the site better. Means that we might have to rearrange where the components are. We might have to fill on both sides. And this is a kind of the playing around to make it fit aspect of the project.